You're very welcome tonight. Thanks for coming along. My name is Dara. I'm going to give you a very introductory talk to GraphQL. It's nice and light-hearted. It's been a long day. Try not to bore you to death with it. We'll get going. That's for the clicker. To test the clicker. I forgot my clicker.
That's fast.
It works, right? I work for Red Hat, based in Waterford. Obligatory, we're always hiring thing, but we actually are hiring in that specific location. So if you want to get out of the rat race in Dublin, you could rent a mansion for the price of an apartment up here. I'm going to start off just by asking like one or two questions, just to gauge the audience. So who here, show of hands, has used GraphQL to some extent? All right, cool. So who in here has some idea of what GraphQL is, even if it's just something a little bit? All right, cool. Then I'm going to just ask this for the fun. I gave this talk yesterday at a meetup that was like a very general meetup. And I asked who in here has written some JavaScript before? Yeah, everyone, no one. I should probably ask who hasn't written JavaScript before in here. So that's cool. Just wanted to get an idea. So we're going to start off with the definition of what GraphQL is. This is what you see when you come on the website. So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API. It's really long and it's really boring, and that's my reaction to it, to be honest. It's pretty far out, if you ask me. I don't know, it's an engineer thing. Like, this is what happens when you try to get engineers to write marketing speak. We like to make things more complicated than they actually are, right? So we'll try to bring it back down to earth. This is going to be super simple, and it's just going to give you a flavor of what it is. And if you're interested, then you'll have to go and do more research by yourself. So it's just an alternative way to design APIs. That's really all it is. A lot of people, when they first hear about it, they think it's like a database or like a graph database or like some sort of language for a database, or it's just a different way to design APIs. That's what it is. And specifically, it's an alternative to REST APIs. So we all know what REST is, right? Just in case there's a single person in here that doesn't, we're going to do a quick recap, right? So you have a client and you have a server. The client wants to ask the server for some information, so they're going to say HTTP GET, right? And they're going to say that to a particular endpoint. The server has some code inside there that knows how to deal with that exact situation, and they can perform it and give us back a result. Really similar again, you might do the exact same thing. You want to ask for some information, but you've added some extra conditions. You've got a query, age is 30. So just like when you go on Google and you search something, you get a list of results back. Again, there's some code in the server to handle this exact case. We call it a handler, right? Most of you know this, I'm sure. And then lastly, we might send some data. So post some data to that endpoint, and there's some code that handles that exact thing. I'm sure there's a load of people in this room that are like rolling their eyes at the fact that I'm explaining this, because I'm going to take a guess that you either don't know this, or you know it so well that you don't even have to think about it. So it's like riding a bike, right? You never actually think about the handlebars and the pedals and the brakes, but they're all the individual components that make up the overall thing. And we get so used to it, we don't think about it. But I want you to think about those, because it's important when you start looking at GraphQL. Because it's kind of, like I said, it's just a different way to do the same thing. All right, so basically, instead of lots of endpoints in a RESTful server, you just have one endpoint, and you're going to send queries to that endpoint, right? So an example query, user, right? So here, this is what a client, like a browser or an app or whatever, another service is going to send to our GraphQL API. So they're asking for a user, and they're specifying an argument here, ID of 1. So we would expect that your server is going to reply with a user object. But not only that, but when you're asking for something, you have to also specify the fields you want back, right? So in this case, we're asking for ID, name, address, right? And this is what the result looks like. So you can see how the structure of the response is very similar to the structure of the request, and that's a really nice thing about GraphQL, because you know exactly what to expect, right? The next thing that I want to get across is that fields are functions. So just like the previous example, we're asking for a user, we're asking for ID, name, address, whatever, right? You can imagine that there's a handler function to give us back that user, right? In GraphQL, we don't call them handlers, we call them resolvers. Now, so you can imagine we'd have a resolver to give us back the user. Then we get down to this friends thing here again. And in a way, it's just another field of the user object, right? But you need a function to actually get us the friends. So fields are functions, right? And you can ask for certain fields that will actually be a function, and you get the result. So probably 2 resolver functions got executed there in our server, right? So that's kind of what it looks like, right? I suppose one of the things before we move on, like around this whole idea that you ask for the particular fields, that's a really interesting thing. Not only because you know what to expect, but because like, why is it like this, right? In comparison to REST. In REST, you don't really have a choice in what you get back. You just get back whatever the server sends. The reason that it was designed this way is because imagine you have one server, one backend, one API, whatever. You have many different types of clients, whether it's a browser-based application or a mobile app for iOS or for Android or for whatever. And all of those different applications might show different things on screen, right? Like as an end user, you're probably seeing different data. And so all of those clients of the one API need different data. So using the one API, you can kind of fulfill that, right? The client gets exactly what it wants. So those are the examples of what queries look like. There is a strong kind of separation that we need to make, is that you have 2 different types of queries. You've got a query and a mutation. It's really simple. A query is just something where the user just returns data, like the top one. You're asking for a user and you get the user back. A mutation is where you ask the server to do something that results in data being changed, right? So whether it's add a user or delete a user, update, whatever. It's kind of like reads and lists and create, update, and delete, right? So it's just an important distinction to make. So that's kind of what it looks like, right? That's a super high level explanation of how maybe a client accesses a GraphQL API, but how does it look like on a server, right? So it all starts with a schema. So in GraphQL world, on the server side, the first thing you kind of do is start out with your schema, like the design of your API. So what is a schema? The schema is basically the definition of all of the business objects that your API works with. So whether it's a user or it's posts or comments or whatever. And it's also a definition of all the operations that your API can perform, right? So it's the queries and the mutations. This is one example way that you can define a schema. You can define schema in code as well, in a sort of JavaScript-like notation. This notation is called Schema Definition Language, or SDL. So it's kind of a really nice high-level way, like you can get like non-developers to look at this and they can understand it to an extent. So it's really nice if you want like product people to like help you with the design of your API up front before you actually write any code. Just to talk about the syntax a little bit. So at the top we're defining a user type. So our application has users, it's got an ID, a name, and an address. They've got types, so it's kind of typed. They say it's strongly typed, but there's not that many types built in, so I kind of argue as to whether it's strongly typed, but you get strings and like ints and stuff. And then you've got type query, so underneath the query type, you've got the list of queries you can perform. So list users returns an array of users. You've got get user, which accepts an ID parameter and returns you one user. You've got a mutation called add user that accepts those parameters and returns you a user. Fairly simple, right? At least I hope. So now that I've given you a super high-level background on what it is, or explanation of what it is, now I'll give you the background. So it's created by Facebook in 2012. One of the main reasons that they created it was because, say, the Facebook browser app versus the Facebook like native mobile app. They have two completely different requirements for the data that gets returned, and they want to be able to satisfy that from one API without wasting any bandwidth on unnecessary data, right? So you can imagine you're in India or somewhere else where you've got a really poor mobile connection, this stuff really matters. So yeah, it was open source in 2015. It's a spec, so it's not like a framework as such. It's more of a, like, it's this really well documented thing that happens to be implemented in lots of different languages. But luckily for us, Node.js people, the reference implementation was done in Node. So that's the first technology it was implemented in. And as a result, the whole ecosystem and community is, I don't know what happened there. The whole ecosystem and community is very kind of heavily geared towards JavaScript, as opposed to any of the other ones. So let me get back to over. There we go. So yeah, super high level introduction. Now let's try to build something, right? So we're going to try and build a small application. So what we're going to build, we're going to build an app like Slack, so a messaging app. We're going to have users, messages, and channels. I'm sure everyone here is like familiar with Slack, right? So a user can send a message to a channel, and the one requirement there is that users will receive messages in real time. That sounds like a super scary thing to try and get done in a demo, but GraphQL has some things that we can use to do that, right? So before we get started, just super quick high-level thing on what the technologies we use. We're going to use Node, obviously. We're going to use a thing called Apollo Server. It's one of the many GraphQL server frameworks there are. Some people would consider this very opinionated. It came from the same people that made Meteor.js, so like that might throw red flags for certain people. But it's all right. What can I say? We're going to use a thing called GraphQL Playground, which is like an in-browser thing that lets us write queries and send them to our server, and we're going to use it in-memory database. Right? So this is how we're going to approach it. We're going to have 4 steps. We're going to just do initial like boilerplate setup. We'll do the schema design. So we're going to design what our schema looks like before we actually implement the thing. Then we're just going to implement some resolvers, and then lastly we'll figure out the real-time thing. Right, so yeah, let's get started. Alright, so this is my editor. Just one second. I'm running on battery and I forgot my laptop charger. How clever is that? Alright, so we gotta do this quick. Right, so I've got a small db.js that just has some sample data just to give you an idea of what the data looks like. We've got users with just name, address, ID. We've got channels, just a name and ID. And then we've got message, which the message has a channel ID because a message gets sent to a particular channel, and it has a user ID for the user that's sent it, right? So really super basic way you model a relational database, right? And it's all just like in-memory type thing. We've got a server.js where we'll set everything up, and we've got a schema.js where we'll define our schema definition and also our resolvers, right? So to start off, yeah, just to go through it a little bit, so we're just using like an Express app. We're going to use Express in conjunction with Apollo Server. I'll make that a little bit bigger. So yeah, like super basic, right? We're getting Express and we're getting this Apollo Server thing. We're requiring our schema from the other file, and then we're like initializing this Apollo Server, and then everyone kind of knows this whole middleware thing with Express. So what we're doing is we're telling Apollo Server to apply some middleware, and that basically mounts like the whole GraphQL thing into our Express app, right? So we're just going to get started by like literally implementing the bears thing to make this runnable. So we have to implement some basic schema and a single resolver, right? So we're going to just start off with a single query. We're going to do hello world, obviously. So we've got a query type. We're going to have one query called hello. It's going to accept a name, and that's going to be a string. We're going to put an exclamation mark, which means it's required, and it's going to return us a string. Right, so that's our starting schema, right? And then in resolvers, our resolvers is basically an object, and it's got a sort of one-to-one mapping with how you define your schema. So at a top level, we've got query defined here. So we're going to define query. And then underneath query, we have this hello field. So we've got, down here, we've got hello. And it's going to be a function. And this function is going to return us our result. Function is going to accept these arguments. And for now, we really don't need to worry about any of them except for the args guy, because the args is going to be whatever args you got passed in. And we can return a result. In GraphQL world, you can either return stuff synchronously or you can return stuff asynchronously by returning a promise, right? So that's really nice now with like async await. You can do some nice stuff in there. So we're just going to return our, right, simple as. And lastly, so what we do is we take the static definition of our schema, and we take the resolvers, and they basically get mashed together in this thing called make executable schema, which comes from this GraphQL tools lib. Yeah, you can see that. And what that does is that basically creates the sort of GraphQL runtime, and that's going to get mounted into our server at the GraphQL endpoint. And it all magically works. So let's see if we can run. All right, so it runs. This is the playground. Let me zoom in a little bit. That's pretty good. So we're going to just do a query, and the query is hello. You need to pass in a name, and yeah. Sorry, yeah, obviously. So we're going to just destructure args out into a name. Really, really basic mistake there. Classic demo. Right, so hello Dublin. Okay, we've got hello world set up. Right, we're going to move on super fast and actually define our schema, right? So what do we need in our schema? We're going to need users, messages, and channels. So we're just going to get started super quick. So we can delete this guy for now and get started by defining a channel, right? So we're going to say type channel, and it's just going to have an ID, and for the demo it's going to be an int because it's just the easiest thing to work with the in-memory database, and we're going to have a name string, right? So pretty much. And what we're going to do, we want to list channels and get channel by ID. So we're going to say we're going to say channels, and that's going to return us an array of channel. And then we're going to have a channel thing where you pass in an ID, and that's an int, and that's going to return us one channel. So we got to just implement these resolvers now under here. So we're going to have channels. And for that one, we don't need to access any args, so we're just simply doing returning db.channels.find, right? This is like, in your real world, right, that's going to be a SQL database or whatever it is that you're using. And we're going to have channel, context, command type. And so we want to get the ID, right? So we're going to just destructure this guy, add into an ID, and we'll be able to return db.channels.get, I think, ID. And restart service. There we go. Let's see, can we get a channel? Or we'll get the list of channels, right? So channels. And remember, like I said earlier on, whenever you request something from a GraphQL server, you have to ask for what fields you want. So we're just going to say we want the ID and we want the name. And there we go. So we got our channels. We're getting close. We almost implemented our entire Slack app, right? So we'll get there. So the next thing, we're going to go super fast through this because I don't want to like bore everyone to death. What else would a channel have? You send messages to a channel, right? So we might do something like this, right? Where messages, where we have type message, right? So now we need to define our message type. and it's going to have an ID. It's going to have text, and we'll leave it at that for now. We'll eventually have the person that sent it. But so, if anyone remembers back to like the super basic example queries I had in the slides where we had like the user and we get the friends of that user, and that's like where a field is a function, right? Really similar thing here with channel, right? So we'll need a function to return us the messages. So basically, like the way we define query and then we have channels under query in the resolvers, basically we're going to have messages under channel, if that makes sense. So we're going to come down here and we're going to have channel, and we're going to have a function called messages. And this function, the idea behind it is that this guy is going to return us the messages for a given channel. So this is like a really nice thing in GraphQL world. You kind of don't really get this in REST, because normally you might get like a list, you might get a link, you know, not in this exact case with the Slack app, but like it's very common that you ask for a resource from a REST API and you don't get back the associated resources. You might get a list of links to resources, and then you have to go and ask for those again. So you might need to make multiple calls to the network. GraphQL allows you to sort of optimize around that and do things in a single call if necessary, right? So there's a performance hit on your server when you do this kind of stuff, but it means that the network, or on the client side, you don't have as much trouble. So with that in mind, back to the task at hand, we want to get messages for a particular channel. So the flow that's going to happen here is, like, let's say we want one channel. This function is going to get called first to return us that channel. Then we're going to see, oh hey, the person wants to get the messages off that channel as well. So now we need to call the messages function. And in that case, this root guy is going to be a reference to the channel object that got returned in the first place. So it's like the parent, right? So what we can do is we can say like, right? We can destructure, or we can take the channel ID off the root ID. So the root is the channel, and then we can like SQL world, right? Just get the messages with that channel ID. So. If it works, I need to restart my server. I'm just going to run this with Node map to make it easier. Alright. Let's see. So messages, and again, I have to say what I want back, so ID and probably text, right? So if it works, we should get the messages also. So yeah, so we have a channel and we're getting the associated messages for that channel as well. Right, cool. Last thing, I swear I'm going to stop coding after this, right? You want to get sender as well, right? I think you're starting to get the idea of like what you can do, right? So we just want to define our type user. And the user type is so easy because it doesn't have any children objects, right? So it's just ID and name and address. And in a very similar fashion, I probably have a syntax error here and here. In a very similar fashion, we're just going to define message with sender, right? Sender. So, and we'll have root, args, and context. And we want to get the sender of a particular message. So that message will have a user ID property, right? So we'll be able to say const user ID. We get it off like this. Go to root, and then we'll be able to say db return db dot users dot get user ID, right? Message.sender. Let's see, what's that called up here? Oh yes, we need to put it in here. So sender. And So we want the sender, let's say name, okay? And we need to refresh because. Okay, so now we can see the person that sent the message. Ooh, okay, so I swear I'm going to stop coding. You might have noticed while I was typing in here as well that you kind of see this auto-completion stuff happening, and that's like a really cool feature of the fact that we use a schema in the GraphQL kind of world, right? So you've got this idea of schema introspection where on the client side you can sort of get an understanding of what the schema is on the server side, and you can really dig into that and see exactly what sort of data the API has or works with and what kind of operations you can perform. So on the client side, you can kind of discover that, right? Which is a really nice thing. And that's coming straight from your code. So you don't have to like manually maintain this documentation or anything. It's just all there, which is a really nice feature. So I hope you get the idea. I know it's like super basic, but basically I don't want to keep coding on this stuff because it's super simple. And we're just going to move straight to the next thing, which is like around real time. So we're going to jump ahead and assume that we implemented all the basic resolvers, and then we're going to move on to how can we solve the real time, right? So basically GraphQL has this concept of subscriptions, which is, it's this concept that lets clients basically subscribe to events over WebSockets. As a client, I can connect to a GraphQL server and basically get notified about events that I'm interested in, and it's the server pushing that data back as opposed to like me polling for it constantly, right? So this is how it looks on a schema level, so it's really similar to how you do queries or mutations. You just define your subscription. This is message added, so imagine we're doing Slack, right? You want to know when the message was added. In this case, that's kind of useless because you don't want to know about any time a message was added in the whole world. You want to know about when a message was added to a particular channel. So just like queries or mutations, you can also supply arguments as part of your subscription. And then on the server side, we can basically see like, hey, is this event relevant to the particular client? And if it is, you can send the data back. Right? So that's kind of the idea. But one more problem, right? So let's say you've got, we're running it in the real world now, and we've got several servers running in the cloud, right? Server 1, server 2, however many. We've got 2 clients connected, and the red client is connected to this server, and the blue client is connected to this server, and it's our Slack app, right? So the red client wants to know about new messages, and the same for the blue one. Let's say the blue one goes and adds a new message. How does that server know about it, and how does that guy eventually find out? So, super simple, you need to have some kind of pub/sub or messaging system going on behind the scenes to allow those servers to talk to each other. Right, so the way it works is like, say in my resolver, like message created, or like add a new message. In the function where I add a new message, I'll basically need to put a message on a pub/sub somewhere so that other servers and myself, our own server, like say I send this guy here, another part of his code base will be able to see the message and all these other guys as well. That's kind of how it works. In terms of pub/subs, you can use pretty much whatever you want, whether it's like a RabbitMQ or some other really popular messaging thing. You can even do like some mad stuff where like Postgres has this notify listen thing, so you can sort of bastardize a lot of databases into being pub/subs as well. Whether or not that's a good thing, that's another story. So that's kind of how it works. So I'm going to jump into a completed version of that in my code just to show you kind of how it looks. So basically, in my demo today, we're just using an in-memory pub/sub because I only have one server, so it would be too much of a pain in the arse to try to set up a real thing. So it's just like, it's like an event emitter basically, and we've got our pub/sub and we've got this special filter function that allows us to do filtering. Like for example, I want messages only for one channel, right? And in our schema, we basically just define our subscriptions. It's super simple, just like anything else that we define. And then the resolvers look slightly different. So let's say in our add message place where we create a new message, one of the things that we'll want to do is publish to a particular topic on our pub sub. So you might have different topics for different events that happen in your app, and you publish a payload on that. And then elsewhere, you're basically listening for events on that particular topic, and you can send sort of like the GraphQL tooling kind of looks after the actual sending back to the clients, right? So you don't need to worry about it too much. You're just sort of wiring things together. And then with the filter one, basically what the filter one does is allows you to add an additional function that returns a Boolean. If it returns true, the message gets sent back to the client. If it returns false, obviously it doesn't. But in there, you can get access to the variables and the payload. The variables is, say, like, as a client, I want to connect to channel ID of 1. Then you have the ID in there, and you can make a decision as to whether this message is relevant for a particular client, right? So that's super simple. Let's try to run it and make sure it works, right? So we're going to cd into that folder. All right. So what are we going to do here? We're going to split this up into 2 tabs. No, don't do that. We're going to throw this guy here. So we're going to subscribe on one side, and then we should hopefully see the thing happening on the other. We'll send a message on the other side, and we should see the message come in. Right, so we're going to say message added to channel, right? And we're just going to say channel ID is 1. Oh yeah, sorry, exactly. Just like with the rest of your GraphQL world, right, you need to ask for what fields you want back. So obviously we're going to get a message on that particular event, and we're going to want, like, say, the text, right? So bang, we're listening now, and then on the other side, when we go to try create a message, say, what should I call it again? Add message. Add message. So we're going to say text, hello Dublin again, from user ID 1 and channel ID 1, right? So we're sending it to the right channel. And we want to get back name. We want to get back the text, right? And we see it come on the other side. Woohoo! So we've got real-time messages, right? That's pretty much enough of what we need for our, like, super nice demo Slack app, right? And I wanted to put together something that looked nicer than this, so I wanted a front end, right? I'm a back-end Node guy, right? So I can build this super simple back-end in 20 minutes or 30 minutes, but then it takes me 2 weeks to build a front end. Managed to do it though, so I will just throw it up there for the fun, right? And we can see will it work. So what are we going to do? In this other thing, here is like a full version with the front end. It's the exact same server code that you've seen, and we're going to try to deploy it, right? So I've got a Kubernetes cluster up in the cloud somewhere. It's very nice. That's its own talk. But we'll try and build and deploy there. So let me see, what version do we have deployed already? This guy, so we want to do a new version, so we're going to say, and then we're going to scripts, build. So we're going to build it, and then we're going to deploy it. So we're going to build a React front end, we're going to do the whole Docker thing. It's going to make an image. The image is going to get pushed, and then we're going to say to Kubernetes, hey, you've got a new version, please deploy that for me. And Kubernetes should behave. And one thing you'll see, it'll pop up really fast. So look, there's one being terminated and there's a new one being created. And if all goes well, we should be able to access it. All right, so it's running. Let's go back to our browser and see, can we get it up? All right. So talk.darahayes.com, it should be there. For demo magic, I'd love to invite if 1 or 2 people can just see if it works for me. So this is what it looks like here on your phone. It will look something like this. You can press this guy to get up the sidebar, and you can press the login, which will just ask you for a name. There's not like an actual login, and you can just go there. And if all works, we should be able to get our real-time messages. I'm waiting. Full bar, that's great. Yeah, nice. Thank you very much. All right, so I know it's like a really trivial demo, and like there's probably some people in here right now that are going like the implementation, for example, where we got a channel and the list of messages and the user that sent those messages. That's a really, really expensive, like ridiculous operation to try to do in real life. And you wouldn't actually do that, right? Obviously. And that's one of the downfalls of GraphQL, is that some of the queries can be really expensive unless you try to tame that, right? So there are lots of ways to do that, but like I can't really talk about that because it's kind of out of scope for today. But yeah, so quick recap. We've got schemas. Schema defines the thing that your API works with and all of the operations. We've got the resolvers, which are the actual functions that implement that. You've got your subscriptions, which is a way to subscribe to events over real time. So, some nice benefits. You get exactly what you asked for. You saw that. You define the fields and you get what you want. This is really nice. This is like one of the main use cases, like for why it was developed in the first place. It's versionless. I didn't really get to touch on this too much, but the sort of common convention in the recommended convention in the GraphQL world is, instead of like versioning your API endpoints like you might do in a REST sort of API, the idea is that, say if you need to add new things, you can add them and that's not a problem, because say older clients basically are still only requesting the older data. If there's new fields or whatever, that's fine. And the nice thing about having this whole system where you need to ask for fields on the client side means that on the server side, we can track exactly what fields a client ever asks for. And over time, you can figure out whether we can remove stuff as well if no one's using it, right? So that's kind of cool. Lastly, schema. So schema is a really nice thing, in my opinion, because it's just a really declarative way of like understanding your API. Like just to give context, I've been working with this stuff like for only about 2 months. Like I'm by no means an expert on it. We're building like this small product in Red Hat for my job, and it's based off GraphQL. One of the really nice things about the whole schema way of doing things is that like we can have like product level people or like higher level architecty people that aren't really involved in day-to-day like coding tasks, and they can get involved on the design as well, and it's a really easy thing for everyone to agree on, right? So yeah, and on top of that then, like the introspection thing that I mentioned briefly, like where we saw the auto-completion in the GraphQL playground, that's a really fancy feature as well, because you don't need to like pay someone to document your API, right? So that's a big plus. Bad thing about it, the queries can become really complex. Like in the demo that I gave you today, for example, you're asking for a channel and you want all the messages, and then for each message you want to get the user. That's like, doesn't actually make sense in real life to do this. There are technologies out there to like do batch queries, like there's this Facebook data loader thing. There are ways to reduce the complexity of your queries. You can do like caching and all sorts of stuff. Speaking of which, you need to figure out a lot of that stuff all over again. So things like authentication and authorization, or caching, or pagination, it's all stuff that's been around for a really long time, and we've kind of solved it to death with REST. And when you start looking at GraphQL for the first time, you really need to figure that stuff out again. And it's doable, and it's not that hard, but there's still an overhead when you get started. You need to go and look that stuff up. And then lastly, I was at the talk that I gave this yesterday at a meetup down in Waterford, where there's not that many JavaScript people, so I had this up. We're obviously mostly JavaScript people in here, but depending on your opinion, like I said, the reference implementation was done in JavaScript, so there's a massive community. Like the JavaScript part of the GraphQL community is probably the biggest part, really, and the ecosystem is very geared towards that. And depending on your personal opinion, that may be a good thing or maybe a bad thing. Who knows, right? So, one more thing, and then I'll let you go. Back to the original definition, right? When I first looked at it, it didn't really make sense, but now when you look at it again, GraphQL is a query language for your APIs. We've seen that. That's pretty simple, straightforward, right? It's a runtime for fulfilling those queries. We just define the schema and the resolvers and put them together, and the engine figures out how to execute it, right? So it's a runtime, that makes sense. Provides a complete and understandable description of the data in your API via the schema, and gives clients the power to ask for exactly what they need and nothing more. We've seen that too. It makes it easier to evolve APIs over time and enables powerful developer tools. So I think that makes sense now. It's not as ridiculous as it first sounded, right? So thank you very much.